Hello, my name is Richard, and today we'll be talking about procedural maze algorithms. And if you think that's a mouthful, wait till you see the code. Let's get started. Alright guys, thanks again for watching and tuning into this one. This inspired me because I was very interested in all of the hype around No Man's Sky right now, which, as you're probably aware, or maybe aware, that it's a game that has procedurally generated star systems, a small matter of 18 quintillion planets, which is a ridiculous number of zeros. I think it's 18 zeros, so the chance of you ever meeting anybody online is slim, although apparently that's a whole new kettle of fish in terms of the actual fact that you can't meet online, but I won't go into that. So I thought, well, how can we do something procedural? And I've always had a little bit of an interest in maze algorithms, and this one here is a particularly popular one. It's called the hunt and kill maze algorithm, and I'll take you through the code. This is actually the second time I've recorded this. The first time I recorded it, I got bored of my own voice. It was so dry and so dull that I thought, wow, I need to do this again. So what I'm going to do is I'm going to go through this quite briefly, just talk you through each of the functions, let you take a look. Obviously, I'll put a link to the Unity package so you can download it yourself, and we'll have a bit of a play so that you can actually go into the maze and try and navigate it. So let's have a look. So here's the maze here. Now, at the moment, I've mentioned the word procedurally generated, but right now it's actually randomly generated, and you can see that it's creating different paths every time. This time, look, it's got this weird long one at the top, and do it again, and now it's got a different path here. Now these are called perfect mazes because there's only one solution. So if we wanted to go from the top left here to the bottom right, there'd only be one way to do that. Now there are various algorithms that can do this, but I find some of them create very, very short paths indeed. Lots of sort of paths like this one where they're very short dead ends. The hunt and kill algorithm is slightly different in that the way it works is it starts at a point here, we're calling it 0, 0. I'm calling it 0, 0, and it starts to move around, and it will move around until it hits a dead end. And when it hits that dead end, that's the kill phase, and then when it goes into a dead end, it goes into what's called the hunt phase. And what it does then is it finds an unvisited cell, and it says, okay, an unvisited cell that's next to an already visited cell, knocks down the wall, and then carries on. If it's next to two visited cells, then it picks a wall at random and carries on. So it can never visit the same cell twice, and eventually you end up with something like this. Now if I just spin over to, here we go, this guy here, jemisbuck.org. I'll put the link into this guy's website because it's brilliant. He's passionate about this stuff. I think he's even got a book out about the various algorithms, and this was the one I chose to go with. It's straightforward enough that you can do it, but not too complicated. So let's have a little run through this. So if I actually run this the first time, you can see what's happening. It's kind of wiggling its way around. Alright, and then off it goes. So my apologies, let's try that again. Phone went there, as you can probably hear. I'm still looking for work. That went very quickly. I'll just quickly reset that and run again. You can see it's kind of darting around. Obviously, this is a visual demonstration of what's going on. If we just reset and we'll step through it, we can actually see what it's doing. It's walking around and it's walking to any available space. And you can see that it's doing okay at the minute, but any second now it ends up here and it can't go backwards on itself. So this is when the hunt phase begins. And sure enough, there it is. It's the top one there. There's only one adjacent cell, so it destroys it and it carries on. And you're going to see it's going to get stuck there because it can't go back. And then it's going to be that cell there because that's the first one. It goes sort of left to right on this algorithm here, and away it goes again, and so on and so on. And this is a pretty fast algorithm. There you go, got stuck again. I'm going to try and find one where it's got more than one choice. Here we go. So now it's going to come down to this row here. Now it's got two choices here. It could remove that wall or that wall because this is not here. Let's see what it does. It removed the wall on the left. Whether or not that's actually always going to happen, I don't know. It should theoretically destroy a random wall, and here you go. You see now it's got itself stuck, has it? Yeah, it's just going to have to go again. No, it can go down. That's right. Yes, of course. And away we go, and so on and so on and so on, until eventually we end up with a rather beautiful looking. Sorry, just go down. Let's do the bottom corner. There you go. So that's it. So I'll send a link to this page. He's brilliant. He goes through a whole bunch of other algorithm types, and they've got exactly similar processes to this to show you how it works. So this is how this one works. It does exactly the same thing, and at the moment it's completely random. And we'll talk about how to make it procedural. So let's take a look at the scripts and the way to get set up. Now the first thing is that it's got this maze cell here. The maze cell is each individual cell, And if I spin over to MonoDevelop, I was going to say Visual Studio there, MonoDevelop, we can see that we've got our very, very simple class here that's just called maze cell. It's got a Boolean visited, which is set to false, and it's got a game object that references all of the walls and the floor. And probably now is a good time for me to show you, let's just stop this, it's a good time for me to show you the wall, which is here. I've just created a very simple wall, which is 6 on the X, 6 on the Y, 0.6 on the Z, so it's created a flat wall here. The reason I made it that big, it was, as I'll show you in a minute, we'll actually use the first person controller to maybe try and play around and see if we can get that steering around, so actually be able to play with it and actually try and navigate the maze. Alright, so that's the actual wall, so that's great and everything, but how does it actually work? Well, the first thing we need to do before we do anything else is initialize the maze to create the cells. And what I might even do, just comment that out so that you can see what it's doing here. So we've got a method here called initialize maze, and it doesn't do a tremendous amount, this. The key thing to notice is that if I was to say on each of these cells that every cell had a north wall, a south wall, an east wall and a west wall, then what would happen is the east wall of one cell would overlap with the west wall of another cell. So what I decided I would do is would only create south and east walls. Alright, so only create south and east walls. Now if I did that flat out, what would happen is the top left and the left hand side and the top side would look blank. They wouldn't have a wall on them. So what I do is I say, well, if it's the first column, then put a west wall down, and if it's the first row, then put a north wall down. Alright, and obviously I've got a floor here. I name all of these as well, so in the inspector we can see what they're actually called. This was a useful thing for debug. It's probably not needed now, as I'm clear. I was having all sorts of trouble with rotation, trying to work out which cell was where, and it took a little bit of time. So this is why I'm not going to go through it with you now. The one kind of obvious thing is that the east wall and the west wall are fine as they are, but we'll need to rotate the north and the south wall so that they face up and down, if you see what I mean. They're facing the opposite 90-degree angle. I hope that makes sense. Like I say, have a play with this and you can see what's going on. So if we just run that initialize maze on its own, I've commented the rest out. Why didn't that work? Did I save it? Probably not. Let's try that again. I'm always forgetting to save it and then not knowing what's gone wrong. There we go. So we've got this really weird looking, not weird looking, it looks like a large egg carton, industrial egg carton that's got each of the cells. And so if I just kind of flick through some of these, you can see there's a west wall there. That's because this is the first column, and then it goes to east wall and north wall and south wall and the floor. Okay, so no, that's the floor for this. Spin that up so we can see that's a bit better. We're in ISO mode, aren't we? Let's just click on Y. Oh, you monkey. There. Something like that. And that's the same for everyone, but apart from the fact that now, from that point forward, the first row always has a north wall. If we just slide down to row 1, the row 1 will have a west wall, an east wall and a south wall, but then it is just a case of east, south and floor for each of these ones there, and eventually we'll get to the bottom and they'll be happy and they'll do the whole lot. Great, so now we've got our maze, our grid. What we need to start doing now is smashing these down, and what I decided I would do is I would create, if I go to scripts here, a kind of hierarchy, an abstract class that would have allow us to create different algorithms if we needed to. This proved to be annoying because it meant I couldn't show you a similar script to this running. I got it all working. It was beautiful. It was speeding around, and I could have shown you something similar to this in Unity, but I couldn't get it working. The reason I couldn't get it working was because of the start coroutine was playing silly buggers with me. I can go into detail if you care, but I won't go into detail now. So let's have a look at the maze algorithm. Nice short algorithm here. For those of you that don't understand too much about object-oriented languages, an abstract class can't be instantiated with the new command. It needs to have a subclass that has that actually implements certain methods here. So you can see I've created a method here called create maze, and you can guarantee then that if your class is of type maze algorithm, it will have a create maze entry. All right, what I've done here is I've just said, well, look, let's get the maze cells. I didn't show you that, did I, in the maze loader? But I create a two-dimensional array of the maze cells, and that's what this is doing here. It's actually creating this. Here we go. Sorry, maze cells here. It's actually creating that array of maze cells there, which we pass into this here. It's slightly confusing. abstract classes can have constructors, and that could blow some of your minds, and I'm sorry about this, but the reason for that is that the subclass could call this constructor, and that's fine because it's not being called directly. Alright, so we initialize the cells and create a reference to them so that we can use them in our implementation of it, and we also get the rows and columns. I could have put that in the constructor here, parameters, but I thought, well, why bother? Why not just get them and get length? That gets the length of the first dimension, and that gets the length of the second dimension. Okay, so in our case, hang on, if we just go back to Unity, I created a game manager, by the way, that this maze loader is attached to. There it is, and you can see that we've got 6 and 12. All right, and the maze loader actually uses those up here. Maze rows and maze columns, and you can see that that's what these for loops are doing. So I'm bouncing around the code a bit here. Hope this is making sense so far. So we've got our maze algorithm, lovely, nice and small. So now we need an implementation of it, and I've created one here called hunt and kill maze algorithm, which extends maze algorithm. All right, and we have a couple of class variables called current row and current column. The reason we do those is that we're going to start traversing it, and the kill and hunt methods are separate, so I want to be able to them to interact with each other by knowing whereabouts they're calling it a drunkard walk. I keep calling it a drunk walk, which basically means a walk anywhere. So basically saying, where are we at this present time? All right, that's what the current row and current column. And we've got this course complete here. So after any hunt phase, if it can't find any empty or any non-visited cells, then that gets set to true. You'll see that in a second. So here we go. So the first things first is we say, well, where are we? Well, we're in 0, 0. The top left-hand side, as I'm calling it, we'll set that visited to true, and that means then that in some of the methods below we can never visit that cell again. And then while the course is not complete, we go through the kill phase. Now, if you may remember from our little demo back there, the kill phase is just this, in quotes, I'm just going to say it now, drunken walk around, going left, right, up and down, but never going back on itself until it hits a dead end. So let's have a quick look at that. The route still available field is saying, well, from where I am currently, can I go somewhere? Is there an adjacent cell that is available to me? So let's have a quick look at that. If I just press that and press F12, it's basically looking up, down, left and right and saying, is it a valid cell to start with? You know, is it within range of the index, and has it not been visited? So you can see this, it could come back with 4 possible adjacent cells, but it's going to return if there are any available. So if I just spin back like so, okay, so saying, right, so if I can go somewhere, then get a direction. And now this is the procedural number generator .get next number. And if I quickly show you that, at the moment, ignoring all this is doing is returning a random range. I'll show you in a minute. Okay, ignore all this because I'm going to get it working in a second. This returning a number between 1 and 4. Right? I know that says 5 there, but it's 1 is the inclusive and 5 is exclusive. So it's going to return a number between 1 and 4 for now. Hold that thought. Okay. What we're then saying is, well, if direction is 1, then go north. If direction is 2, then go south. If direction is 3, then go east. And if direction is 4, go west. Now, let's imagine that we're at 0, 0, and this number returns 1. And you're going to say, well, hang on a minute, that's not going to work because surely north is out of range. And indeed, this little script here, what this does is it says, is it a valid cell? It's saying, well, is the row 1 and above? So if it was north, then for this to return true, that would need to be 1 or higher. And indeed, if it was a south, then don't return true if going south would take us out of the range. And the same for the columns, and also the fact that it hasn't been visited. And it does that for all of the possible options, north, south, east and west. So it's saying, right, so if we're going to go north and north is a valid entry, then destroy the wall if it exists, the current north wall, and destroy the wall if it exists, the wall above us, its south wall. Now, again, this is overkill because I only create south and east walls. We're never going to destroy a west or a north wall, because the only west and north walls that get created are the ones that are the outer wall, so you never want to destroy those. I put this in there because I just thought if I ever change it then I'll get confused with this piece here. So it's a bit of overkill, so we're destroying 2 walls if they exist. I'll just quickly show you what that looks like, and it's just saying, well, if the wall's not equal to null, then destroy it. Alright, now you notice I've got game object there, and that's because this doesn't extend mono behavior, so I have to call that method on it. Right, and again, so all this is doing the same thing over and over again. So it's saying if it was south, and south is a valid cell, a valid row, destroy the south wall and the one below its north wall. And also you can see here, so we're going to go up a row, and we're going to go down a row. And here we're saying if direction is 3, then east, and the east cell, or the one to the right, as I like to imagine it. If it's a valid one, then destroy that east wall, and the one to the right's west wall. And finally, west, it's going left, so is it available to us? If it is, then destroy this west wall, and the one on the left's east wall. And here we're adding and subtracting the column. Alright. I hope that's making sense. It might be worth getting the debugger out just to have a play if you're not happy. And then obviously once we're there, it's going to say visited equals true. Now if this didn't actually do anything, so if we went north on the first wall, it would sort of do that twice, because we already set it to true up here, and every time we reach a new cell. So potentially it could actually just be running over and over. That doesn't matter. We can set it to true. We know that it's been visited, and we can do it multiple times. So this has the potential to get stuck in a loop of hitting 1 for a while, but eventually it'll choose the right entry that will get it out of its way, because it's a random number, so it should eventually get the right direction. And it'll keep doing that until it gets stuck in a dead end. Once it's done that, it exits this loop, and then we go into the hunt phase. And the hunt phase, it's quite simple, really, as you can see here. It's going to go through each of the rows and each of the columns. It says, is this column visited? All right, remember that's the flag that we had here, equals visited. Excuse me. Okay, so if that's false, and cell has an adjacent visited cell, there you go. So there's a mouthful. Right? Let's press F12 down here. What this does is it looks at where we are now, and a bit like the script that checks to see if it's a valid row, it looks to say, are there any adjacent cells that aren't visited and are available. Alright, so again, that's showing the possible adjacent cells. So it could return more than one. Alright, it could return more than one, but it's checking to make sure if there's at least one. So saying if there are any adjacent cells, then okay. Oh, I should have said this before I started. Course complete is true. So we're going to make an assumption that actually there's nothing left to check. There's nothing left to check, but if we've got this stage, then actually there is more to check, because we've just got into a cell that has an adjacent visited cell, so we need to do something. So we'll set it to false. The current rows are, current row column is C. You can see that from the for loop there. Destroy an adjacent wall. Let's take a quick look at that. That picks a random wall and just does very similar to the other piece in that it's just going to destroy it, and then finally it sets the current cell visited to true and exits the function. And it will keep doing that. Okay, this course complete is true here. If it gets through this without finding a single unvisited cell that has an adjacent cell, then course complete will be true. So this here will end. All right, so it's going to run multiple kill phases, multiple hunt phases, until the hunt phase sets course complete to true and doesn't change it, and then it'll exit. How about that? How about that? That's a mouthful, isn't it? So let's have another look and run that now, and just have a look and see how that worked. We can probably actually you can see what I didn't do was I didn't update the maze loader, because I think I commented out this maze algorithm here. So let's just uncomment that. Okay, do that. Come on, unclick. There we go. Thank you very much. And we'll click it. What actually we could do, I think this went badly wrong last time, but what I could potentially do is, under the hunt and kill algorithm here, I think what I can do is if I just show you the kill phase. So I'll just do that. So we're just going to do one kill phase, and then you can see how that looks. So let's do that now. Let's have a quick look at that. So if we run this, you can see what it's done. It's gone. It starts here, by the way. I've noticed that my game is actually upside down. which is fine. It started here, always starts top left as I view it, and then goes right. It's gone right, look, and then it's gone down, down, left, and then let's get this right. It's gone east, south, south, west, north, and it's got stuck. It's got stuck there because it can't go down, it can't go left. So now it would enter the kill phase. Let's just try this. Let's just try that. Oh, the hunt phase. Excuse me. I'm sorry. I got them round the wrong way. And I did the first video I did. I was calling hunt kill and kill hunt, and I can imagine that people would have got very confused. So thankfully, right. And what's happened here? Now it's gone a nice long way, hasn't it? It's gone all the way, and I'm pretty sure that's the cell it found. Okay, so it's gone down there, around there, around there, around there, around there, around there, around there, and got stuck there. And then it's come back up, and if I want to draw an imaginary line there, it's come here and it's this is the first cell here that has an adjacent cell that's been visited, and it's knocked down that wall, and it would have carried on. Alrighty. So now what we'll do is we'll do the whole thing. Bang. Alright, there we go. And now it's got all the way round. So it's gone round there, round there. I'm guessing it got stuck there by the looks of things. So it would be my guess it's gone round there, got stuck there. Then it would have started there. It must have gone down and round or something like that, maybe. I'm not sure anymore. It's quite hard to tell how it would have done it. But you get the idea. If you were playing a game where you had to get to the bottom right, then there would only be one way to do it. Now, one thing that you may be noticing is that at the moment this is completely random every time, and the reason for that is that whenever I wanted to get a random number, I use this procedural number generator, which I've created, by the way, get next number. All right, that's a static. Oh, look at that! It's got a lowercase g. I should change that because I know that. This is my Java background. I'll make sure I change that. So if we go and have a look at procedure. There's a few places that happens, by the way. So like where it gets an adjacent wall to destroy as well. Here you go. Procedural number generate get next number. I think actually that might be the only two places it calls it. So there's a couple of places where it needs a new number. If we look here, I wonder if I just change that pref2. I wonder if that'll throw an error. It'll work here. I wonder if it'll update the hunt and kill algorithm. Where are you? Where are you? It did! Classic, there we go, capital G. Hooray, hooray. Technology works. So what I did, so let's actually remove this now. Let's just do this. Let's just do this, guys. I created a key of 1, 2, 3s and 4s. Now remember, 1 is north, 2 is south, 3 is east, 4 is west. I think that's the way around. So I created a random number of these, sort of, 1, 2, 3s and 4s. Now I don't know if that's any good. I don't know if that's a good set of numbers. You see I've done quite a few 4, 4, 4s actually. 4s seem to follow, but you might want to make that quite large if you're using a very large maze. But for now, that's what I go with. And what I said was, well, look, let's get the current position. So current position starts as you wouldn't know it, would you? But let's just start that as 0. Okay, and then we're saying, right, what's the current position? Right, sorry about that. I got another phone call. Maybe I will get a job. You never know. Right, so this is this string here. So what I've said here is that the current position plus, so this is incrementing all the time, %key.length. All right, now this is the key here. If you don't know what that means, that's going to return the number of characters here. Let's say that's 20. And this returns the remainder. All right, so this is going to say 0, it's going to return 1, 2, 3, or 4. All right. Okay, so it's going to say what position are we? What's the number in position key.length %key.length? So if it was a hang on a minute. Have I got that wrong? No, that's right. Excuse me, sorry. For a horrible second, I thought I got that wrong. So it's going to return a value somewhere between the 1 there and the 4 there. And once it goes past that, it will start back at the beginning again. Oh my goodness, I thought I was only using the first 4 characters then for a sec. Whew! Yeah, so it's going to go with all the loop all the way through. And when it reaches the end character, it's going to start again. And it just returns one character. So it's going to return 1, 2, 3, or 4. And then what we do is we say return int.parse what that current number is. All right, So current number there. So if I was to put 5 and 6 in there, this thing would blow up. But so it's relying on the fact that I'm being honest, and it's 1, 2, 3, 4, or 0, or A, or something like that. Or that might, well, 0. This would work, but if we put A in, it wouldn't work. All right, I'm hoping that makes sense, guys. Apologies, I babbled my way through that, but all this is doing, this is a modulus command, and it just returns something. If it was at %4, it would return 0, 1, 2, or 3. It basically returns the result, the remainder of a division. All right. Okay. So now what this is going to do now, it's going to go through those things. It's going to go north, south, east, west, south. West, north, so on. It won't always be able to hit these, a bit like the random number, but at the point, if it doesn't, it will go on to the next one. And now, if I just save that and go into here, click play, we'll get a maze. There it is. It's got a very long corridor there that doesn't do anything. This is quite a good one, actually, isn't it? That you can see there's different ways you could go wrong. But the right one is, where is the right one? It's that one, isn't it? Go down there, across there, that's it, through there and down. Assuming I'm going bottom right here, by the way. And if we do it again, click it again, we'll get the same maze. Hooray for procedural generation. This isn't the best procedural generation algorithm, I know that, but you get the point that it's going to return consistent values over and over again. I had some thoughts about how you might want to play around with this. Perhaps use the day as this key here. You'd need to obviously work out a way to change the days to 1, 2, 3, 4 in my code, but potentially you could do it to the current day, year, month, day, and then that would be guaranteed to be the same maze for one day, and then the next day you get a completely different maze. Could be fun, I don't know, just a thought. Different things that you could do with this key here, but for now this is actually a static key. Alright, and that's going to create the maze the same every time. And that, guys, is the code. But I thought that just as a little extra, just as a bit of fun, I think it would only be fair that we tried to navigate this maze actually by diving into there. So let's do that now. Alrighty, so to do that, what we're going to do is we're going to make sure it's not running. And then we're going to, where are we? We're going to be kind to me, those assets. We're going to import package. The characters. Now I'm never 100% sure which ones to use, so I'm going to just select everything. Alright, and I click import. Now that's complete overkill for what we're after here, but let's just put that in there. Come on. I'll pause this while it does this, and then I'll unpause it when it's finished. Okay, that's finished. Now, one of the problems I have with this, of course, is that this thing is procedurally generated at runtime. So if we create a first-person character, they're just going to fall into the pit. So what I'll have to do, I think, if I go standard assets, characters, first-person character, prefabs, FPS controller, just drag that in, just reset those to 0. All right, that puts them there. Now, if I just actually, what I'll do is I'll set the Y to something like 10. So they're high in the sky. Let's just see how this goes. Just click maximize on play there. Let's do that. Click that. Let's try this. Perfect. There you go. So what happened was it dropped it through the sky, and we can start walking around our maze. Now, I already can't remember which way it was. I think it was this one. Just press shift and go down and then round. Actually, I didn't actually know. I don't actually know if this is the right way because I didn't have any indication of how to know if it's the right way. But I'm pretty sure that will be a dead end now. Oh, hello. Maybe not. Am I going around in circles? That's not possible. There we go. Oh, I am going around in circles. I didn't think that was possible. Ah, there we go. That's why. Oh no, there we go. That's it. That's it. That's the end there. If I just quickly press escape and pause. Where am I? First person controller. No, I'm not. I'm nearly there. Look, I was there a minute ago. I've gone past it. I've gone round and up. So actually, I followed a big old path there. This is a very small maze, by the way, so we could potentially make this a lot bigger. Let's do that by going back to the game manager here, which is just an empty, by the way, with a script added to it right now. Let's make that 12 by 18. Again, the rules will, because we're using this procedural number generator, this will be fine. It'll just loop round, and we can click on play. Look at the size of this bad boy. Oh my goodness, right, look at that. You can see it's the procedural numbers I've created a lot of these extra doors here, lots of little spaces here. You can see by the way I added a texture to the wall. You're welcome to do that. You don't have to do that. Alright, okay, let's just, what I'll do now is I'll turn off maximise on play, and then we can have a look at it. There, oh, have a look at this. There you go, that's a beast, isn't it? But it is a perfect maze, in that there's only one solution to get down to there. You can very easily get lost. But have some fun. I will put links to the code and the Unity package. It won't include the first person character, so I encourage you to just simply import that and do what I did there. Just use the first person controller, just setting 0 X and Z to 0 and Y to something like 10. Alright, I'll let you decide if you want to make a game out of it. But guys, I really hope this. What I'm going to do now is I'm going to delete him. I'm going to delete him now. I'm going to delete him now so I can just finish just showing you what this looks like. Alright, let's delete that and delete the editor. Lovely. Alright, so we're just left with what we started with now. Should we just click that? There we go. Alright guys, I hope that was really useful. I hope that was fun. I hope you take a look at the code, play with it, enjoy it, and create the next version of No Man's Sky with one almighty hunt and kill maze algorithm. I wish you all the best. Until next time, thank you. Bye bye.